Welcome to the Zumwalt-class ship brief. So the Zumwalt-class is a very unique design added to the United States Navy, going all the way back to the 1990s when they were designing LCS and Zumwalt at the same time. For the upcoming century, the new Navy was going to be escorted by these large-sized destroyers and escorted by many LCSs, accompanied eventually by unmanned surface vehicles to be the new American fleet around our nuclear-powered carriers. That was the vision. And the Zumwalt was the destroyer, the large surface combatant of that vision. Well, things didn't work out the way that they intended, the Navy intended, and they ended up only building 3 of these destroyers. And we're going to go over the systems and capabilities of this destroyer, which is very modern, very capable, especially being designed in the 90s, and the things that also did not work, and the changes that are being made to the Zumwalt now to correct those. So this is the first surface combatant to employ the integrated power system. What that means is the prime mover, the engines, the turbines that would normally be mechanically linked to the shafts are not. There's no mechanical linkage between the engines and the propellers. There is, in between those two things, the IPS, the integrated power system that stores electricity made by those turbines, literally turbine generators, and then distributes that power to the screws, the hotel loads, the combat system. IPS is the heart of the ship, and we're going to go over that in detail. They did plan on building 32 of these monstrously large destroyers, but for cost reasons and some system design failures, they only built 3, and then they stopped. They stopped the program. No more Zumwalt classes are ever being built again. Now, the weapon systems that they have are very unique. They have 80 Mark 57 VLS cells. They can shoot 80 vertically launched missiles of all sorts, including the ESSM point defense missile that is a 4-pack. So you get 4 missiles in one of those 80 VLS cells. They have 2 of the Mark 46 30-millimeter gun systems. That's the same 30-millimeter gun system that's used on the LCS. And it suffers from similar problems. We'll go over that. But the big one is the 255-millimeter AGS naval guns on the bow. The guns work great. They're installed and work fine. The thing that does not work fine is how much each round cost. The round that is GPS guided and rocket assisted that gives it such enormously long range, over 150 kilometers, and a pinpoint strike capability at that range because of its technology, cost $1 million a round, which is ridiculous. The Navy said no. That triggered all sorts of tripwires in terms of cost overrun that forced the Navy to take this weapon system off this platform, and they did. That's happening right now. They're replacing it with conventional prompt strike, CPS, hypersonic missiles. And all 3 of them are getting that installed. So the weapon systems as of right now are the AGS 155-millimeter gun on the bows. Those are underneath those triangular pyramid-looking covers to give it low radar observability. Along the side is the Peripheral VLS, peripheral meaning along the side of the ship. We'll talk about the pros and cons of that. And then finally, behind the superstructure but above the helicopter hangar are the 2 Mark 46 30-millimeter gun weapon systems. For sensors, she has the standard kit, a sonar system on the bow called the SQS-60, has both medium and high frequency. The SPY-3 radar, which is the specific variant for the Zumwalt of the SPY system. SPY-1 going all the way back to the Ticonderoga. SPY-6 is on the new variant of the Arleigh Burke. SPY-3, Zumwalt. Above that is the SPS-73 radar. This is the navigation radar that's on over 100 U.S. Navy ships right now. It is the standard navigation radar, but it has a lot of capability. And we'll go over that in detail when we get to it. The little balls, if you will, that stick out from the side of the Zumwalt superstructure is the Electronic Warfare Suite. This is the SLQ-32 Alpha version 6 with the SWEP Block 2 upgrade, which is the second most advanced upgrade in the Navy right now. This is what protects the ship from being detected on radar at all, and then if it is attacked by a missile or other sensor, it can obscure its IR signature. Obviously, its radar signature is obscured. It can even obscure the visual shape of the ship if the sensor is using thermals or some other than visual spectrum. It is very advanced and also very secret. We can't talk about it, but that's what those balls are. They're to defend the ship from electronic eyes and sensors. And then off the tail end, you can't see it because it's below the waterline, is the SQR towed sonar array. It's part of the SQS 60, 61, 62 sonar family. All right, Zumwalt-class destroyer. They built 3, all in Austell, USA. That's down there in Mobile Bay, Gulf Coast. They commissioned Zumwalt in 2016. Her sister ship, the Mansour, in 2019. The Lyndon B. Johnson commissioning was delayed because the decision had already been made to take off the guns of the bow and put in the CPS hypersonic weapon system. And so the Navy made the right choice, in my opinion, to not commission a ship, assign a captain and a crew to it when it's just going to sit in the shipyard for the next couple years getting these weapon upgrades. So that's why the last of the Zumwalts has not been commissioned yet. It's literally just like a manning issue. Also, a rare example of common sense being exercised by the U.S. Navy to not stick 150 sailors on this thing and sit in a dry dock while shipyard workers finish it. Well done. Okay, the Zumwalt-class destroyer by the numbers. The heart of the ship is the integrated power system. It is powered by 2 Rolls-Royce MT-30 turbine generators. They control everything on the ship based on IPS. Remember that, because all the ships building going forward in every modern Navy is integrating their power systems and becoming essentially electric boats, electric ships. So this 16,000-ton ship can be pushed with this electric motors to 30 knots. That's the public number. Obviously, it's a little bit faster. But the endurance range, look at this, 20 knots to go 4,500 nautical miles is really very efficient, especially in a ship that's this size and displaces 16,000 tons of water. That is a very fuel-efficient endurance range. Normally, you'll see these knots measured in 15 to 18 knots, not 20. And that may not sound like much, but over 4,500 nautical miles, those extra 2 or 3 knots means an entire day. It means a lot. So the crew, like I said, is about 150 people. That includes officers and the enlisted. They have room on board for an augmented crew of about 28 to 30 people. That would be the mission supplemental crew. And the way the Navy works now, and this is kind of a modern version of how we used to do it, is when we go on mission, we would bring on additional specialists. Sometimes they would be civilian with very high clearances too. And we would go off the coast of another country and we would just do our mission over there, and the specialist would do their job in secret. Like, we weren't even allowed to talk to these guys. And then if they needed to use sonar, they had free reign of the entire ship. You know, they could do whatever they wanted to. So that's what that extra 28 is. That's just a specialist attachment to a ship temporarily for a mission or a deployment. The 80 Mark 57 VLS can shoot, like I said, the Tomahawk, all the standard missiles, including the ESSM point defense missile, and the ASROC VLS, which is a vertically launched torpedo. It has 2 Mark 46 gun weapon systems above the helicopter hangar, 1 port, 1 starboard. And it is currently being installed as a large missile vertical launch system, LMVLS. So they have the PVLS and the LMVLS, easy for me to say, whenever it gets finished. Okay, the SPY-3 multifunction radar is the specific spy variant for the Zumwalt. SSQ-90 Tactical Sonar Suite is what you call the suite that connects the towed array to the hull array to the high frequency and medium frequency sonar systems. If you're talking about all those as one suite, it's the SQQ-90, and then each subsystem has its own name. SLQ-32 Alpha Suite Block 2 obviously is the ECM I talked about, and she can also take on a helicopter and 3 MQ-8 Bravo Fire Scouts, which are UAVs, unmanned aerial vehicles, or she could just have 2 manned MH-60R helicopters. Either way. Most likely, if the Fire Scouts are available, she'll go underway with them because it's more efficient. Those things can stay in the air like 15 hours compared to like 3.5 for the MH-60. All right, the integrated power system. This monumental shift in thinking about how to propel and power a ship at sea, including submarines now, was just amazing. It just changed the way you think about ships, essentially. And the Zumwalt-class was the first one to implement this from original design to implementation. And there were lots of hurdles to overcome, and she did. And having the reliability of a Rolls-Royce MT-30 gas turbine engine that simplified, if you will, this process was a great benefit. Very expensive, yet very light and powerful turbine generators. The Type 45 Daring British ship has the same IPS system using the same Rolls-Royce engines. And together with our UK allies, we implemented this type of propulsion and power generation, if you want to think of it that way, on our ship simultaneously. So we learned our lessons together and shared information. Here's the Rolls-Royce MT-30 gas turbine. It is the world's most powerful marine turbine generator set. It's derived from the Trent Aerospace engine that Rolls-Royce builds, and it's fully electronically controlled. It produces 360 megawatts of power, which is insane. That's a lot of power for a relatively low weight engine, which is what you want. You want high power, low weight on any vehicle. And that's what they have here. And it spins about 3,300 RPM. Here's the Spy 3 radar. Those are those flat panels you see around the top of the ship. So this is a 3D radar. It's AESA, which means it's an active electronically scanned array. It sees in all directions, and it doesn't have to sweep like you would think of a typical radar. When it's in volumetric mode, it sees all directions all at once, and so there's no lag between the updates, which is extremely advanced. It has 5,000 transmitters and receiver elements, which means when one element fails, you can literally pull out that one specific element and replace it instead of having to replace the entire array. That is a huge advance in terms of logistical support and keeping the ship operational. You don't lose your entire array if you lose one or more of your elements. The range of this radar is in excess of 300 kilometers, which is quite a long distance. And while it's scanning this huge area of airspace and surface, it can track surface contacts too. It can track hundreds of targets while also launching missiles and directing those missiles onto multiple targets simultaneously in this huge volume of air and sea space. And those missiles can be the SM-2, the SM-6, ESSM. Tomahawk missile doesn't need updates like that. It works differently. A key benefit of this system is that when she's in a fleet and they're linked together with their combat information systems talking to each other, she can instruct another ship to use its payload, and that can be an unmanned ship that accompanies our fleets now, to use their ordnance so that Zumwalt doesn't use its own, forcing it to have to go back and reload. So it could tell an unmanned sea truck, essentially, launch your SM-6 at this target. Sea truck does that, and sea truck is unmanned. Sea truck expends all of its ordnance, and unmanned goes back to San Diego and gets new weapons while Zumwalt stays on station the entire time. That's the vision. That's what we're looking for. And that's actually what the Navy is achieving here. An Aegis destroyer can do the same thing. The new Constellation class, even the LCS, is at sea right now with unmanned sea trucks with it that carry weapons. So this has all been implemented. This is one of the success stories of the Zumwalt-class and this new way of thinking that the Navy did. All right, here's the SPS-73 version 12 now radar. This is the navigation radar of the U.S. Navy. It's the way to think of this. It's extremely accurate, powerful, high fidelity, which is what you want when you're operating near a shoreline, because you don't want to get crept up on by, say, a buoy that got knocked loose of its mooring and is just out there floating around. You don't want that banging into the side of your ship. I've seen that happen before. Whenever you're going in and out of port, they have channel markers, which are buoys that are big metal things that float a couple hundred yards apart from each other, and you're supposed to go in between the middle of them. This radar will light up those buoys on the radar display like it's a Christmas light. And so you can see very clearly where the channel is. And if you're starting to stray towards one side or another, this is the radar that shows you, hey, you're a little too close to the port buoy. come starboard a little bit. That, for example, that's how this radar is used. But one of the great things about this radar is it can track contacts that run at speeds up to 210 knots. So those are drug-running go-fast boats. Those are unmanned surface vehicles that are being very effectively used against the Russian Navy right now. It can see all of those. And even, of course, helicopters at 210 knots. So very capable, over-the-top with options navigation radar. The Mark 50 PVLS is developed and manufactured by Northrop Grumman. Stands for Peripheral Vertical Launch System. It is basically just an advanced VLS. This is specific for the Zumwalt-class. They don't have this on any other class right now. It has 80 cells in total. There's 20 bow and 20 on the stern, and then you got port and starboard sides, total of 80. It shoots everything, SM-2 to SM-6, the Tomahawk missile, and even the vertically launched ASROC missile, which is the vertically launched torpedo. This ILC'd in 2016 with the commissioning of the USS Zumwalt. The system, again, is not on any other ship at this time. Now, a pro and a con to this design. This was very controversial whenever they designed it. The Navy approved it and said, we're going to try this on this ship. By having your missiles outboard of your vessel like this, they are more susceptible to direct fire damage and fragmentation damage. If you get into a firefight, a near miss can still damage one of these cells of missiles. So a block of missiles would be 20. They would be divided into 5 different cells of 4 missiles apiece. Typically, that cell shares the same fire control intricate circuitry in the VLS. If that VLS cell is damaged, all 5 of those missiles no longer function, even if they're not damaged. So you could be knocking out chunks of missiles 5 at a time if they take any damage at all to the internal components. On top of that, these things are missiles. They have rocket fuel on board. So obviously they could burn easily, and the warheads are designed to burn and not explode if it's just fire. But if you add concussive force to that fire, they most certainly will explode. So you're putting your vertical launch system in a position that is the most vulnerable place on the ship, outboard. Now, the benefit to this is if it does take damage and it catches on fire and it even explodes, the force of the explosion is directed up and out away from the ship. You're not ripping your ship in half because of a magazine explosion. That's the benefit. Weapons slightly more vulnerable to damage and loss of chunks of missiles 5 at a time. But you're adding to the survivability of the ship by not having a catastrophic explosion to a magazine failure. Those are the 2 perspectives on this. Feel free to argue which is better at your will. The reality is this is what we have on 3 ships. All right, here's the AGS 155 millimeter naval gun. Not a lot to remember here because they're being taken off, but I figured you should know that these are 62 caliber barrel guns, basically a very large artillery gun. They shoot 10 rounds per minute. Obviously, they have an autoloader in there, and they shoot the LRAP ammunition, which is GPS and INS guided. That's internal navigation guided, and it's rocket assisted, which means after you shoot it, it's got a little rocket to push it even farther. And that's how you get these ranges of like 150 kilometers. And with the GPS INS guidance, you get pinpoint accuracy. You get the best of both worlds. Shore bombardment was the dream in the 1990s with these shells showering specific targets. So you did not need to bombard a beach like they did in World War II. You would shoot 50, 60, 80 of these things in a 10-minute period and completely wipe out any kind of beach defense, and then push the Marines on the beach when the beach defenses have been significantly reduced in capability. That was the idea. And it works, by the way. So why'd they rip them off? The reason why they did is because the projected cost of each shell was significantly less than $1 million. I forget exactly the number, but it was relatively cheap, and the Navy agreed to pay that amount. But that was assuming that BAE and making these shells would be making shells for 30 ships, which is a lot of shells. There was cost savings in volume because you weren't paying as much in supply chain costs to make a limited number of shells. Because they reduced the number of ships to 3, the number of shells that they were going to end up making went from being tens of thousands to just a couple hundred, which jacked up the cost for each shell to be close to $1 million. So because of that, that triggered all sorts of budgetary red lines that said, if you go over this cost on all these different systems, then take the system off. Well, that cost per shell forces the 3 Zumwalt classes that we built to take the system off and replace it with something. The Navy decided to replace it with the conventional prompt strike missile, hypersonic glide vehicle. That's the story behind the removal of these naval guns that do work, but it's just too expensive to shoot. All right. Another gun that works very well is the Mark 46 30mm gun weapon system. This thing is the Bushmaster Mark 44. The Army uses it on some of their vehicles. The LCS uses it. This thing is really reliable. It puts a lot of weapons, a lot of lead downrange. 200 rounds per minute of a 30mm shell is quite something. The muzzle velocity is actually higher than the guns on the bow at 1,200 meters per second and has a range of just under 7 kilometers. Very accurate. The downside of this gun is the same downside as it has on the LCS. It doesn't have much depression. It can't look down and shoot down. So if you get an unmanned surface vehicle within a couple hundred yards of the Zumwalt, nothing on board the Zumwalt can defend itself from it. And that's what's happening to the Russian Navy and the Black Sea Fleet right now, is these unmanned surface vehicles that are very small and fast and attack at night, and they're hard to find on the radars that the Russians have. They're able to get close in and then detonate alongside the ship by ramming it. This ship, the Zumwalt-class, is vulnerable to those attacks if it doesn't destroy those UAVs before they get within 5 kilometers. Look at the minimum range of this gun. You get within 5 kilometers of this, nothing on board this ship can touch you. Unless a man comes out with a sidearm and fires at you, which is literally what the Russians are doing to defend against USVs right now. There is no close-in weapon system on the Zumwalt. All right, SM-6 SAM. This is manufactured by Raytheon. This is the holy grail of all surface-to-air missiles. It can shoot down the most advanced fighter at ranges in excess of, I'm going to say 100 nautical miles. The actual range obviously is not public. It's very long. And I don't care what generation fighter it is. The SM-6 has a very good chance of shooting down a maneuvering F-22. There's no guarantees in that, but that's what this thing is designed for. It'll shoot down whatever's flying, including ballistic missiles. It also has a mode that if you wanted to, you could shoot a ship with this thing. And it has enough kinetic energy and a medium-sized warhead to do some damage. I don't think you'd be sinking a ship with it unless you hit it multiple times. But you never know. So the range, here it is, in excess of 100 kilometers with the booster motor, which is in the picture you see here. 30 kilometers in altitude, so obviously all the way up to where ballistic missiles are going to be. The max speed of this missile is Mach 4.5. Obviously, it doesn't do the entire flight at that speed. It just peaks out at that speed and then maneuvers. It does have mid-course guidance and updates and its own terminal RF seeker. Like whenever it's in ballistic missile mode, the impact vehicle has little propellant jets around it to kind of force it into the kill window. And it's a kinetic kill, hard kill vehicle. It is a very good missile, but it's also the Navy's most expensive missile at $5 million each. So even testing these is an enormous cost. But we do have them in the fleet, a limited number of these. Here's the RGM-109E Tomahawk Block 4. This is the long-range land attack missile that's been around for decades, very reliable, relatively low cost compared to the other SM missiles, and very accurate. I OC'd in 2006 as this block variant. Obviously, we were using Tomahawk missiles all the way back in the Gulf War of 1991. I'm not aware of any earlier uses than that. There might have been, but this missile's been around a long time, and it's extremely accurate, which lowers collateral damage. It hits military targets, and not much else is the idea. And the Zumwalt was really going to be used, in my opinion, to support land attacks with those guns that could precisely demolish a beach defense, combined with this Tomahawk missiles. You know, out of the magazine of 80 missiles, say 60 of them were Tomahawks. You know, this one ship could support a Marine landing. in it. Also, with all the other marine amphibs, ship supports a very likely chance of success of the marine landing happening. So this, in my opinion, really is a land attack ship first, which is a change in paradigm thinking from the Navy. The Navy's always been air defense and then anti-ship, anti-submarine. And then this ship is clearly anti-land warfare or support the Marines on the beach warfare with also air defense capability. So it is a very interesting way of thinking. It's a wonder what would happen if we did actually build 30 of these and then support our Marines around the world, if there would be more land action. I don't know. That's a counterfactual at this point because it's not happening. But we're building 3 of these, and the Tomahawk, I think, was going to be the primary weapon of this ship. All right. She also has the capability of shooting torpedoes vertically with the VLS. This is basically just a Mark 46 or Mark 54 lightweight torpedo on top of a booster that you see there. And it goes to a specific distance and drops in the water with a little parachute. And then once the seawater hits the torpedo, that torpedo has a seawater activated battery. So the seawater gets in there and gets the anode and cathode going back and forth, which produces power for the little motor. And then it just starts spinning, looking for targets. And that's kind of how that works. All right, here's the conventional prompt strike missile developed by Lockheed Martin. It's a lightweight hypersonic glide vehicle. They're going to have 4 missiles per module, and they're going to have 3 modules on each one of these. So 12 missiles is what I'm told right now. Obviously, these haven't even been installed yet, so we'll see how many there actually are. And we'll have that number updated whenever the first one comes out and is tested. The reason why I'm hesitant about that is because they could do 4 missiles per module, and the Chief of Naval Operations told Congress that there would be 12 missiles, but he might have meant all 3 ships are going to get 4 missiles leading to 12. That is another possibility. We won't know because it's not public until they actually build it and test it. And then we'll be able to look at it and be like, yeah, there's 4 tubes right there. So we will see. Either 4 per ship or 12 per ship. We'll know whenever they do the testing in a couple of years. All right, here's the MQ-8 Charlie UAV. Remember, they can have 3 of these and a MH-60 helicopter working together. This is the unmanned helicopter. Can stay in the air for 15 hours. Has a starlight radar option, including electrical optical sensors. This is great for doing missions that require close to visual investigation without risking human life. A common practice or employment of this type of unmanned aerial vehicle in the United States Navy, in the 5th Fleet, which is Middle East right now, is the ships, fishing ships off the coast of Yemen that are seen trafficking towards the Strait of Hormuz, Iran, and back again, will be followed and inspected by unmanned aerial vehicles like this, because those ships are likely to be carrying weapons. And one way of catching that is by employing this UAV, seeing that instead of fish on the deck, they have weapons crates under cover, and then they conduct a boarding action and confiscate those weapons. That has been a successful use of this UAV recently. She can obviously do many other missions, but I wanted to give you an example of a real-world employment of the MQ-8 Charlie. Now, that was done from another vessel. It wasn't done from the Zumwalt-class. All the Zumwalts are in dry dock or preparing to go to dry dock to get these weapons installed right now. All right, final thoughts. Man, okay, multi-mission ship, focused on land attack, but had the ability to control airspace and even ballistic missile defense. Cost overruns reduced the number of ships from over 30 to 3, which pushed the cost per unit up significantly because of supply chain efficiency cost. And that triggered the removal of the gun system on the bow. That's how bad it got, because each round became too expensive to shoot. You know, every time you wanted to test you were spending millions of dollars on just the round. You know, it was ridiculous. And so obviously the Navy wisely and Congress wisely said, all right, if we can't use the ammunition, we can't use the gun, let's replace it with something. And hypersonic technology is coming in to operational availability now here in the United States. A few other countries already have it. We're getting it on our ships now. So we'll see how that goes when those tests are made public, which should be in a couple of years, and we'll bring that to you here, okay? All right, everybody, this has been the Zumwalt-class ship brief. Thanks for watching, and we'll see you next time.